So, hi guys, today we'll look into the second part of mass information block, that is MIB. So previously we have read theoretically, right, some points regarding MIB. Now we will see what all information elements are there in the MIB. So maybe we can call it as log analysis of MIB. Okay. So we are looking into IEs, right? What is broadcasted from the network, basically, or base station to UE in master information block. So master information block is a part of SSB, right? And in SSB we have this PBCH that contains MIB. Now very first information element is your system frame number. So system frame number, its total bits are 10, but only 6 MSB. Most significant bits are carried by your this MIB. So how do you determine the rest 4 bits? So rest 4 bits will be determined by PBCH transmission. So it is kind of similar to LTE only and via channel encoding. So when you combine both of these 2 bits, it becomes a 10-bit version, 10-bit size of block, and this will give you the range from 0 to 1023, right? But you remember in the MIB box, the SFN has 6 bits reserved, right? Now, second thing in the MIB, right? Second thing we have subcarrier spacing common. So I'll write it here. Change it. Subcarrier spacing common, right? Now, it could be represented as, I mean, it depends basically if it is FR1 or FR2, right? So it's it could be represented at SCS 15 or 60, and second way is SCS 30 or 120. So if it is denoted by this very first one, it means if it is FR1, it will consider 15 kilohertz. And if it is FR2, it will consider 60 kilohertz. For second notation, SCS, subcarrier spacing, if the frequency is FR1, this is 30 kilohertz. And if it is FR2, then it is 120 kilohertz. So this is the second point we have. Now coming towards the third point. So third point is SSB subcarrier offset. Change this maybe. Okay. SSB subcarrier offset, right? So here this SSB subcarrier offset would be indicating the frequency domain offset between the SSB and the overall resource block grid in the number of subcarriers. Okay. So this is in frequency domain. So this would be denoting your frequency domain offset. Frequency domain offset. Now as the name suggests, right? SSB subcarrier offset. How much offset is there for the SSB to start, right? And this would be in terms of subcarriers. So frequency domain offset between the SSB and what I told you, overall resource block grid. Right? So it can also be represented via KSSB. Let me write it down. KSSB. So if you remember, there is a diagram, right? You know, where all these things are mentioned. So maybe let me pull out the diagram for you. This one is different. Where is the diagram? Okay, so here we have this diagram. So if you see here, so just see here this starting point, absolute frequency point A. Now you see this RB0 to RB3, right? From RB3 to KSSB 10 subcarriers, and then you have this 20 RBs for your SSB. So this offset to RB, right, is known as KSSB, from where your SSB is starting, right? And this is denoted in terms of subcarrier. This is 10 subcarriers given for example, right? So we move towards the next part. I'll explain this diagram in the later videos in detail, okay? So don't worry about that. Okay, so SSB subcarrier offset would be indicating the frequency domain offset between SSB and the overall resource block grid in number of subcarriers. So one more thing, this field may also indicate that this cell does not provide SIV1, okay? And that there is no common CORESET available, okay? So उस केस में क्या होगा? In this case, the field PDCC config SIV1 may indicate the frequency positions where UE may not find SSPBCH with the CORESET and search space for SIV1. But just remember this offset is just KSSP, okay? Slowly you'll learn everything. Next is your DMRS type A position. So DMRS is downlink modulation reference signal, right? So downlink modulation reference signal, this would be indicating the position of first DL DMRS, right? And this is basically L1 parameter, and this is specific to type A position, okay? So you can say this would be indicating the position of DMRS, downlink modulation reference signal, right? It is in downlink, it means it is coming from your GNB to UE. Coming towards the next part, next is your PDCCH config SIV1. Now this is very important here. PDCCH config SIV1. Okay, so this contains, this is a total of 8 bits. I forgot to tell you this TMRS type A position, right? So this, how much bit is there? DMRS, this is basically, this would be indicating position 2, position 3. So if you see here, right, this DMRS type position is of 1 bit. First SFN was of 6 bits, subcarrier spacing common, FR1, FR2, this is 1 bit, and subcarrier offset, that is your KSSB, this is of 4 bits. Then we have PDCCH config SIB1 that contains control resource at 0, search says 0, that is of each 4 bits. This is your MSB. This is your LSB, right? So here if you see, right, PDCCH config SIB1 is very, very important parameter because the first 4 bits would be telling you the CORESET index, right? The CORESET index, that is CORESET 0, that is from 0 to 15. Now in 3GPP specifications, we have this table, right? We have this table by which you can, you know, like 13.1 to 13.10. There are certain tables related to CORESET that would be telling you what is the size of CORESET in the frequency domain, like 48 RBs, how much symbol it is occupying in the time domain, like 1 OFDM symbol, right? And what is this multiplexing pattern, what is the offset? So these all things you can find in 3GPP specifications. So I'll share you that 3GPP specifications later on, like what is that exact 3GPP specifications. But let's focus on next things here in the MIB. So next thing here is your cell barred. So basically it will be telling you your cell is barred or not barred. It means whether U is allowed to camp on cell or not. So this is also 1 bit. Next is your intra-frequency reselection. It means if your UE is allowed to have intra-frequency reselection for this cell, so it could be allowed or not allowed. Again, this would be indicated by 1 bit. Now this is pair is 1 bit, size is 1. So this is total is 23. But if I tell you the MIB size is 24 in total. Okay. Now you will ask why. So the answer is MIB contain a total of 23 bits, but an additional bit is used for BCH message type indication, right? Let me write it down here for you. So an additional bit is used for BCH message type indication. Right? So which makes total of 23 plus 1. 24 bits in 5G NR. Okay, so this is basically our log analysis, or you can say the information element that are present are MIB. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So 8 information elements are there, and 1 bit additional that is used for BCH message type indication. So this total becomes as in 24-bit MIB, right? And it goes via logical channel, that is your BCCH, transport channel BCH, and your physical channel PVCH, right? So I hope there should not be any doubt. It should be clear till now. So guys, if next thing is if you want to compare the LT MIB and NR MIB, so there are certain points there. So like very first point, this point is pretty much similar, broadcast channel. So this is PBCH and BCH. So PBCH is your physical channel and BCH is your transport channel. This is same for LT as well as NR, right? Second point is resource allocation. So in LT, as you have seen, right, 6 RB, 72 subcarriers. In frequency domain, it was using and 4 symbols of first subframe. Second slot symbol 0, 1, 2, 3. So this you can refer LT. Now in 5G, we have recently seen in our previous video that it is transmitted on OFDM symbol 1, 2, and 3, right? And it uses 0 to 239 subcarriers on 1 and 3 odd symbols. While for symbol 2, it is like it is divided from 0 to 47 and 192 to 239 subcarriers. Third thing is modulation scheme. So it uses almost same modulation scheme QPSK for LT as well as NR. In LT, the periodicity was 40 millisecond generation periodicity and 10 millisecond retransmission periodicity. But in 5G, we have 80 millisecond of generation periodicity and 80 millisecond of repetition periodicity. If we talk about the channel coding here, so in LT, we used tail bit convolution encoding, and in 5G, we are using polar coding. So these question could be related to your interview aspect whenever you are giving interview. So every time whenever their question would be from 5G, right, it should be compared with 4G. What different do you have? So you can remember these points. The difference here is in resource allocation, periodicity, and channel coding. Rest two things are same only, right? So guys, I was talking about the specifications like which would be telling you the core set in the search space. So this is 38.213, version 16.4, physical layer procedures, right? 3G specifications. In that you have this 145 page number, I guess. Yes. So there is a table 13.1 that is would be representing your core set. So the first is your index 0 to 15 that we have seen, right? 4 bits of MSB. PDCC config siv1 would be giving you this core set index, and then you have SSPBC's multiplexing pattern. So and this offset RBs, these are basically complementary. So how much offset you have in the frequency domain for this core set. Number of RBs in the frequency domain, number of RBs, it is spanning like 48, 24, 96, depending on the index. And number of symbols in the time domain, 2, 3, 1, how much it is occupying, right? So from 13.1, and how these tables are differentiated. So these tables are differentiated on the basis of SSH, PBCH block and PDCCH subcarrier spacing. If it is 15, and second thing is minimum channel bandwidth is 5 megahertz or 10 megahertz. Similarly, you have 13.2 where both the SCS are 15, and but minimum channel bandwidth, you can see here operating with, okay, so this is different. This is 13.1A. So this is for operator with shared spectrum channel access. So this we are not concerned with. 13.2, this is where this PDCCH and SS block SCS is 15 and 30 respectively, and minimum channel bandwidth is 5 and 10. So according to the index, this will change number of RBs and offset, right? So this is basically a configuration related thing, like whenever you run some scenario or test case. So on the GNB server with the network and the UE and all configured, so there could be some configuration related issue where you can refer this table from the 3GPP specification for specific to control resource set, and accordingly you can configure this. If any issue is coming, like number of RBs are less or some offset issue is there or number of symbols, you can change, right, in the configuration. So this is like 13.10, this is would be telling you core set, and I guess from 13.11 it is your search space. So yeah, so this table would be for your search space. Like I told you, PDCCH config siv1 parameter in the MIB, right? The least significant bit, 4 bits, would be representing your search space. So accordingly, this table is designed. So maybe you can refer this, or we can discuss this table also in detail in the later part when I would be explaining more things, so we can include this, right? So there is one more thing I want to discuss here, that is there are two types of SSBs are there. So one is your CD SSB, that is your cell defining SSB, and second one is your NCD SSB, non cell defining SSB. So your cell defining SSB would be pointing to the core set, okay, of SIV1. So let's say this is your some CD SSB. This is your NCD SSB, and this is your core set for SIV1. Okay. So what will happen? The CD SSB would be pointing to the core set of SIV1, cell defining CD SSB. And if UE is decoding the NCD SSB, now NCD SSB would be pointing to cell defining CD SSB. So there, then UE, what UE will do, UE will decode the CD SSB, then it will go to SIV1. So two kinds of SSB UE can decode, either CD SSB or non-CD SSB. In case of non cell defining SSB, there is one more step involved. That is, first it will go to CD SSB, then again it will decode the location and go to the core set of SIV1. So this is basically high level overview how this decoding takes place and how UE reaches to the SIV1. So I'll meet you in the next class of our BWP and CORESET. So let me know if you want any video on other topics. So we'll make video on that as well. Okay. Chalo, see you then in the next video.